On the western edge of Copley Square, where Boston keeps its most polished ambitions pressed against the sky, there is a building that almost destroyed the city's most beloved neighborhood before a single person moved in. It stands 790 feet tall, 60 stories of blue-green mirrored glass throwing the clouds back at themselves, a tower so thin and so reflective it sometimes disappears against the Boston sky entirely. Millions walk past it every year. Most assume it has always been this way. Clean, finished, inevitable. They do not know that the greatest glass skyscraper ever built in New England spent years covered in plywood. They do not know it was trying to kill people from the moment its first winter arrived. They do not know that the building standing in Copley Square today is not the building that was designed. It is a substitute, a corrected draft, a monument to the failure that tried to erase it. This is the John Hancock Tower. And this is what Boston paid to learn that novelty and beauty are not the same thing as proof. Henry Cobb stood before the city's commission with a sketch that seemed to defy gravity. A single, impossibly thin plane of glass, tilted 45 degrees against the Boston grid. The geometry was not an accident. Cobb wanted the tower to turn away from the street, to catch the sky at an angle, to dissolve into reflection and shadow so that Trinity Church would always remain the anchor of Copley Square. The building was to be both present and absent, a landmark that refused to cast its weight on the neighborhood it overlooked. Cobb called for an undifferentiated sheet of glass, a surface so seamless it would erase the boundaries between building and air. The tower's rhomboid footprint, rotated from the city's orthogonal logic, was a deliberate act of deference and ambition. In presentation boards, the tower hovers behind the church, its mirrored skin holding the clouds and light, its edge a silent frame around the stone geometry of Richardson's masterpiece. The client, John Hancock Mutual Life, demanded a headquarters that would be unmistakable, yet Cobb promised a building that would almost disappear. To achieve this, conventional window framing was rejected. Mullions, those visible bones of most skyscrapers, were forbidden. Only a continuous, floor-to-ceiling glass curtain would do. Every technical choice bent to this aesthetic commandment. The building would not be a stack of offices, but a single, unbroken gesture, a modernist monolith that would assert itself by trying to vanish. In this pursuit of purity, the design team set aside caution. The dream was clarity, silence, and the illusion of weightlessness. The risk was that the glass would have to do more than reflect the sky. It would have to hold the tower together. The facade engineering team placed their bet on a system that had never been proven at such a scale. Each panel, 4 feet wide, 11 feet tall, was a double-glazed unit, 2 sheets of glass separated by a 1-inch air cavity, sealed at the edge and meant to act as both barrier and mirror. The panels were not assembled on site, but fabricated as whole units in distant factories, then shipped to Boston in crates, ready to be slotted into the building's steel skeleton. This unitized approach promised speed and precision, but it also meant that once the panels left the shop floor, there would be no chance to rework or retest them in the field. The design called for over 10,000 of these mirrored panels, each relying on the integrity of its perimeter seal and the bond at the edge. The system's elegance was matched by its fragility. The glass itself was strong, but the assembly depended on a continuous, unbroken seal to keep the elements out and the structure intact. Shop drawings captured the ideal geometry, but there was no precedent for how these panels would behave when stacked 60 stories high, exposed to Boston's wild swings of temperature and wind. Mock-ups were built, but the tests were partial, short-term, small-scale, and optimistic. The leap from laboratory to skyline was made on faith. No full-scale thermal cycling, no comprehensive wind loading, no simulation of the relentless contraction and expansion that a New England winter would bring. The team pressed ahead, confident in the numbers on paper, convinced that their proprietary assembly would hold. The tower's promise of visual silence came at the price of technical uncertainty. a wager placed on innovation without proof. Across Boston, the new tower rose as a shard of blue glass, slicing into the skyline with a confidence that felt almost supernatural. Admiration gathered in the city streets and in the pages of national magazines. From a distance, the tower seemed to have solved the problem of how to be monumental and invisible at once. The surface was flawless, the geometry precise, the promise of modernity absolute. But admiration is not evidence, and the glass was only a mirror, reflecting the city's hope back upon itself. Beneath the surface, uncertainty pressed in from every direction. The public saw a completed building, but no one outside the project team knew how little had actually been proven. The glass panels, so seamless in the sun, had never been tested through a full New England winter. The proprietary seals that held them in place were untried at this height, under these winds, through cycles of freeze and thaw. The city's faith in the building was a kind of collective trance, a belief that beauty and novelty could substitute for proof. Yet the tower's real test had not yet arrived. The structure that now stands in the skyline is a corrected substitute, a monument not to the triumph of vision, but to the consequences of mistaking elegance for evidence. The public's awe would soon collide with the physical reality of untested ambition. On a frigid morning in January 1973, a 4x11-foot panel of mirrored glass slipped free from the Hancock Tower's 33rd floor. It fell in silence until it struck a streetlight in Copley Square, shattering into a spray of fragments that scattered across the frozen pavement. The incident was not a fluke. Over the next year, 65 panels would follow, some crashing to the ground, others removed in haste after cracks spidered through their edges. The city's illusion of safety dissolved overnight. Sidewalks around the tower emptied as word spread. Glass could rain from the sky without warning. City officials, facing the prospect of further disaster, ordered plywood sheets nailed across the entire facade. The mirrored monolith became a patchwork of raw wood, its promise of seamlessness erased in a single week by a municipal mandate. Plywood, not glass, now reflected the winter sun. Building inspectors patrolled the perimeter. Police cordoned off the streets below. Inside, the project team counted the cost. More than 10,000 panels had already been fabricated, packed into shipping containers stretching 600 miles if placed end to end, now useless or unsafe to install. The tower's elegance had become a hazard, a public spectacle of failure. Its danger was measured in splintered glass and the silence of empty sidewalks. Inside a laboratory chilled to winter's edge, engineers pressed the Hancock Tower's glass panels through cycles of heat and cold, measuring the response not in theory, but in fracture and failure. The neoprene seals, those slender black gaskets that promised both flexibility and strength, began to shear apart under the relentless push and pull of Boston's seasons. Tests run by the American Society of Civil Engineers revealed that after 1,450 cycles, the edge seals failed, the neoprene creeping and delaminating until the outer pane stood loose, vulnerable to the next gust. The glass itself was not defective, it was the system. The untested marriage of glass, air cavity, and neoprene, betrayed by scale and by a faith in numbers unproven at 60 stories. The original concept's elegance had become a liability, and the building stood in need of radical intervention. Forensic teams traced the path of each failure to the perimeter, where differential thermal contraction forced the outer pane to shrink faster than the inner. The neoprene, meant to absorb this movement, instead transmitted a shearing force, pulling the panel free. Accelerometers mounted on the upper floors began to tell a second story. The steel frame was not simply swaying, but twisting in a slow figure-8 motion. In high winds, opposite corners of the tower moved in counterpoint, amplifying the load on each fragile seal. Site workers described the sensation as standing on a ship's deck in heavy seas, an unnerving, rolling twist that no calculation had predicted. The diagnosis was clear. The tower was not only shedding its skin, but moving in ways its designers had never imagined. The solution was as sweeping as the failure. Every pane of double-glazed ambition was stripped from the frame and replaced by more than 10,000 sheets of 3/8 of an inch single-pane tempered glass. Gone was the air cavity, the untested neoprene, the fantasy of a floating mirror. In their place came a conventional curtain wall, aluminum-framed, anchored, measurable, and real. The new skin was less pure, but it held. Behind the glass, engineers turned to the unseen crisis, the tower's slow, twisting dance in the wind. 2 tuned mass dampers, each weighing 300 tons, were hoisted to the 58th floor. They were steel giants encased in oil, tuned to the building's natural frequency and moving in perfect opposition to every gust. Their silent motion absorbed the energy that once threatened to tear the structure apart. The retrofit took 17 months and an additional $100 million, pushing total cost to $175 million, more than double the original estimate. The tower finally opened in 1976, 3 years late, its elegance preserved by the brute force of engineering afterthought. What stands in Boston's skyline is not the building Cobb drew, but a monument to the price of disregarding the limits of proof. The glass now holds, but only because every rule of caution was learned the hardest way. Today, the tower glitters above Boston, an icon not of vision fulfilled, but of ambition checked by reality. Its mirrored skin is new, its lessons older than steel. When beauty outruns evidence, disaster is never far behind. The skyline remembers what architects would rather forget. Share your thoughts below.